So, well, piece of advice to anybody who finds themselves in remotely similar waters. The signal that you are on the right track is that stuff starts canceling. Complexity in the story, which has accumulated because something was missing, starts disappearing in the story. You begin to take on a model. Anyway, so yes, we've got a situation where we've got a bunch of drugs mysteriously producing heart damage.
So now you've got a paper that's out. You've got a real world application. You've got a theory coming out of evolutionary theory. It's making a molecular prediction.
Yep. Successfully predicts mouse telomeres.
One of the world's leading labs has confirmed the prediction.
Yep.
Where are we now? What year is this?
Oh, God. Well, let's see. The paper came out.
And my recollection, and just to be horrible about this, is that your fucking department at the University of Michigan, which has some great people, is also holding you back and enervating you year after year by not allowing. Because this is groundbreaking stuff. This is Nobel quality work, at least one or two times over, in my opinion. Now, I could be wrong. I'm biased because of your brother. I'm your brother. But what concerns me here is that you are not comfortable with what this story really might be.
No, I'm look. It's not mine to judge. I'm very proud of this work and the work.
But the problem, Brett, is that Jerry Coyne and Richard Dawkins did not know that Dick Alexander, Leonard Hayflick, and George Williams were all on this thing because that community had broken down.
You know, the irony is I sent a letter to Dawkins when this was going on asking for his help, and he sent back a letter saying, this is very interesting. It's not my area of specialty. You should talk to Bill Hamilton. And I was in the process of writing a letter to Bill Hamilton on Dawkins' suggestion at the point that Bill Hamilton came back from Africa, he was pursuing a remote hypothesis about humans having accidentally unleashed AIDS into the world with polio vaccine. But anyway,
so Bill Hamilton, I'm sorry, not everybody's going to know. This is the guy who came up with inclusive fitness.
Yes, he was one of the great geniuses of evolutionary biology in the late 20th century.
And he was held back by John Maynard, right?
I don't know that story. I
think Maynard is interviewed on Web of Stories.
Maynard Smith,
Maynard Smith, right?
Yeah,
and Maynard Smith talks about, it was very unfortunate. I didn't really understand who he was. You should check it out. It's pretty amazing.
Well, as long as we're doing this, years after this story had cooled, I ran across a paper from John Maynard Smith's that I now don't remember exactly what its nature was, but it appeared to predict my whole story, right? And John Maynard Smith was dead. I couldn't contact him. I really wanted to say, oh my God, you nailed it, right? But anyway, so I was in the process of writing to Bill Hamilton to get his help. He was sort of on a par with George Williams, and he went into a coma on his trip back from Africa, having contracted malaria. And then there was, I think, complication with aspirin that he took or something, and he never woke from his coma, and he died tragically. So he never got the letter, and who knows what he would have done. But
okay, but look, that's a tragic and interesting story. But Hayflick was positive towards you, Williams was positive towards you, and Dick Alexander. Those were the three that blew me away. That's a huge amount of firepower.
That's a lot of firepower, and it wasn't enough. But here's the punchline to the story, effectively. At the point that my paper is out,
right,
and it very directly alleges the danger with these drugs being released when they're not safe, and the drugs have started emerging and turning out not to be safe, and the government is now really interested in what's going on. The government puts together a FDA commission to study the question of the book that they put out. Literally, a book that they put out at the end of their study is called "The Future of Drug Safety."
I hope it's a blue ribbon panel.
It's not exactly clear what it was. What is clear is that you can search the manuscript of this book. Nowhere does it mention mouse.
Antagonistic
pleiotropy. It doesn't mention antagonistic pleiotropy. It doesn't mention the genus mus. It doesn't mention telomeres. It's not in there. It's alleged in the literature. in broad daylight that this is what is causing the problem. And
well, now this is the vampire effect where you don't exist if nobody reacts.
right. And so I start going to members of the press. I think this is a huge goddamn story.
Oh my
Somebody
God,
is going to
you're
make a
self-promoting.
career on it. And I call up members of the press, and it's always the same, right?
Always the same.
It's always the same. They're very excited about this story.
No,
This
they're
is-
initially,
Right.
the reporter
The reporter is excited.
Yeah.
And then the reporter,
talks to someone.
they talk to someone, and then either they stop returning your calls
Yeah.
or they say, I'm sorry, the story doesn't hang together. It's again and again and again.
Yeah.
And there's just nothing you can
Do
do.
you remember what I said about the distributed idea suppression complex?
Yeah. And the people who man it don't even know what they are for most of them. They don't know what role they're playing.
Well, you see the same thing with like string theory because none of the reporters are actually string theorists, so they're dependent upon this. You saw this with this woman alleging that she had the Epstein story 3 years earlier, but that the editors said, well, we might lose access to the baby pictures of the royal grandchildren. Like, you're seeing this with Catch and Kill. There's this, I mean, I want you to take this seriously. You're just showing a part of what I'm calling the DISC, the Distributed Idea Suppression Complex. We have 50 years of such stories.
Yep.
And it happens that in our family, 3 out of 4 of us created such a story trying to get a PhD. And the idea for me is that every time you have to go into some closed system, like there's a committee meeting, or there's a blue ribbon commission, or there's a peer review process, or there's a, what do they call them? The panels, study groups for grants. That's where the DISC lives. We know that it's localized to the things that protect the integrity of science. It's an autoimmune disease where what we have is an ability to stop highly disruptive ideas from getting a hearing in the general population of experts by virtue of the fact that a carefully chosen group of experts can stop publication. Because look, if you're wrong about this stuff, there's a cost.
Yeah.
It's not cheap.
No, I mean, in fact, it would have been career ending. I'm pretty sure had I been.
I don't know that it would be career ending if it was done in good faith, but this is my problem with this is that you're sitting on one of the great scientific stories. And I would say that I've ever heard, but I'm sort of kind of saying, well, Brett, what happens next? Obviously I know a lot of this stuff. I've forgotten it, but I live this with you.
Yeah.
And this is, I can vouch that this is more or less the order of events as it was taking place, as we didn't understand what was happening.
Yep. So I have to go through the final Carol Greider chapter in order for this story to fully make sense.
Where the Nobel Prize is given?
That's the very tail end.
Make sure you include that.
Okay. So at the point that my relationship with Carol is changing its tenor and she is becoming hostile and I'm not clear on what's going on, I contact her and I discover through talking to her that she and Mike are about to publish their paper on the long telomeres of laboratory mice.
So this is the delta between wild type and laboratory mice.
Yeah. And I'm shocked because she's told me they're keeping it in-house. And instead, they've got a paper that she says, in final revisions. They are that day submitting their final revisions to nucleic acid research with their paper. And I say, Carol, can I see the paper? And she says, yes. And she sends me a manuscript, not the preprint of the paper. She sends me a manuscript of the paper, no acknowledgments, no figures. And I contact her and I say, can I see the acknowledgments and the figures? She sends them to me. And I contact her and I say, Carol, I'm disturbed. This was my hypothesis that you were testing. I should probably be an author on this paper, but at the very least, I need to be an acknowledgement in this paper so that I can go back and point to it and say
It changes everything, that it was a prediction. It wasn't just something that was stumbled upon.
Absolutely.
Yeah.
And her response is, I have been through my email and I see no evidence of the communications you are talking about. Now, when I said at the beginning that
called her,
I had called her. That was my error.
This is such fucked up. I mean, I don't swear a lot on this program.
Yeah.
But this is such fucking academic, petty, stupid ass bullshit. This is like one of the great stories of all time.
It's one of the great stories of all time, maybe, and human life hangs in the balance on this. No kidding. One, right? Okay. So Carol does get awarded the Nobel Prize. Carol, Greider, Elizabeth Blackburn, and Shostak. Shostak, who mentions at the point that the Nobel Prize is awarded that he was shocked as all hell to get a Nobel Prize because his work was so deep in the history of telomeres that we just didn't expect it. And suddenly...
No, I should say, I want to be very clear, right? Yeah. All of these people have made fantastic Nobel-worthy discoveries. There's zero allegation that these people
weren't deserving. No,
absolutely.
No. And they, Carol and Elizabeth got their Nobel Prize for the discovery of telomerase, which is a huge progress. So anyway, I don't deny that they were worthy of this prize, but what Carol Greider does with her Nobel lecture, right? Nobel lecture being the biggest lecture a scientist will ever give, the lecture that...
And filmed,
is she delivers a paper in which she very oddly has now embraced my entire set of hypotheses about the effect. She has come over from the comparison between the paper of mine that she panned and said didn't make any sense. She is now a total convert to the idea that senescence across the body is being caused by Hayflick limits that are telomere-based.
Okay, and this is the first public incident that we know of in which the delta between the negative comments on your paper, which is not an anonymous peer review. We have that.
We have it in an envelope from her.
Got it. And it's immediately after the Nobel Prize that the wisdom of that line of thinking is embraced.
Right. But there's more to the Nobel lecture. So she spends her Nobel lecture on what is admittedly a very beautiful presentation of the connection between telomeres and senescence. She goes through tissue after tissue, says cirrhosis of the liver is what happens when you have short telomeres in your liver, etc. She goes through tissue after tissue. She projects the data, the blot actually, from the paper with Mike Heeman, the paper that I should have been a co-author on.
Yeah.
She projects it on the screen. But she does some weird freaking dance where she, instead of describing the long telomeres of laboratory mice as a major bug in the system, she describes it as a happy accident, effectively, because it allows us to test certain things. Like, oh, isn't it delightful that they have long telomeres? And it's like, what the hell are you doing? There is so much writing on correcting this, and you're presenting it like it's just a bonus. And she, in her presentation, she's got several experiments that I did not know she had run that I had suggested to her. I said, things like, Carol, do you have any idea if a cell has many different telomere lengths? Is it the shortest telomere that controls how many reproductions a cell can do? And she's run that experiment. Interesting. Lo and behold, it's the shortest telomere. Well, it's a good guess. But anyway, so she goes through this. There's no mention of me. There's no mention of the actual implications of the long telomeres for things like science and safety testing and all of that. And I can't seem to raise the issue of the safety question with anybody, right? At best, I get journalists who are interested until they call somebody, and the somebody's on the other end. I know what they say. They say, everybody knows that mice aren't great models. In fact, there's a paper out there that says something like, the mice lie. It's not about this issue. It's just about the fact that mice aren't a perfect match. The issue in question could be solved. It could be addressed thoroughly. And for all I know, once the Jack's lab figured out what they were doing, for all I know, they quietly have fixed this. And there was a I've heard that there was a private meeting in which they decided.
Look, this is the thing.
Yep.
you see something like this in statistics. Everybody knows that most distributions that are bell-shaped are not normal, right?
Yeah.
And on the other hand, we all use normal distributions. Yeah. And as a result, there are lots of things that at one level everybody knows,
yep,
but don't percolate down to the important layers in which we test things. And I don't know where, like you and I have never been able to fully put together, because we're not molecular researchers and I'm not even a biologist. How important are these results? How robust are they? Has there been a change? This is a quiet world at some level.
It's a quiet world, but I think what I have concluded, working backwards from the phenomenology of the field and how it reacts to this problem, is that there's a tremendous amount resting on failing to acknowledge the error, even though the error was obviously an honest error to begin with. They would rather sweep it under the rug. I mean, imagine you've got all these knockout mice, right? These knockout mice, there's a major investment in them. It takes a lot of work to knock out a particular gene.
You've got a single point of failure,
right? Whose
projections are tendrils into everything,
right? And you've got how many careers built on papers that are now suspect.
This is like a centralized irreproducibility crisis.
Yes, it's that bad or worse.
Okay,
and you know what happens if, let's say, somebody hears this podcast and they check into it and they find out, lo and behold, this story is true.
Yeah.
Well, now the FDA has a problem.
Well, wait a second. I don't want to get too far out over our skis. We have enough listeners that people will get a chance to hear an unbelievable story. And if there are things in the story that are not true or misremembered or unkind, or there have been changes, or maybe we don't really fully understand how the drug testing works, I'm open, and I want to be very clear, and I want this in the podcast. I'm open to the idea that the most straightforward implications of the story are subject to adjustment. However, having lived the story, I can say that this was an egregious story at multiple points, with conflicts between the evolutionary community, the biomedical community, the professional publishing community. This is a terrible story. Yeah. And it's also an amazing and beautiful and wonderful story. And, you know, I felt really lousy at the beginning of this podcast, goading you and prodding you, but I am so bored of you, no offense, as the guy who stood up to the funny kids at Evergreen. Yeah. And, you know, we know what's in the heads of these people. If you're at Evergreen, you're not that good.
Yep.
Right. And that was like, this is the, I just want to be open about it. Like,
no, I appreciate it. And I'm glad to have this story out. The story has many different layers of meaning. I remember where I was when I finally sat down to watch Carol Greider's Nobel lecture. And I had one of the oddest experiences of my life. I was actually in a hammock watching her lecture, watching her present my hypothesis without my name anywhere on it. And then she projects this image from her paper with Mike Heeman, and I was flooded with two simultaneous emotions that are just completely incompatible, right? I've never felt anything like it. I was absolutely elated to see my work projected on a Nobel stage, right? That changed me.
You know what I call the horse and rider problem?
No.
The point of the official complex of science is to knock the rider and take the horse, where the horse is the theory and the rider is the attribution.
Well, this was it. I was elated and livid simultaneously. And I can still almost feel what it was, almost like my body was trying to figure out, was one half supposed to feel one thing and the other feels the other. But this story has many levels of importance. Personally, it gave me the ability. I was already, as you are, very good at not being persuaded by the fact that everybody else disagrees with you that has an implication. Every great idea starts with a minority of one, and you have to be able to endure being alone with a great idea in order to advance the ball significantly. This story was so extreme and so clear in the end that it just left no doubt. And I must say, I don't know how young students can arrange to confront material so that if they're really good, they get a clear demonstration like this, that they're really good, so they know to keep going.